should see on your client side permission to begin recording what you are saying. So everyone has their individual say in that, but I'm at least going to be recording what I'm doing. So, good morning. Good morning. More people will probably be filtering in, and that's why I'm filming it for those who show up late. So, welcome to our virtual classroom for 2 weeks. Again, this is just the school is presently planning for this to be a temporary thing. Regardless of how the semester plays out after these 2 weeks, I promise you my help and support in making sure that this class is a success for you guys. We've survived one transition mid-semester to online learning. We'll survive another one if it ends up being that way. But currently, the whole purpose of this is just a 2-week plan for right now. And we're going to operate under that assumption that we'll be meeting back together shortly. For at least these 2 weeks, though, any direct new instruction will be done via these Google Meet calls. And previously, the last time I did this, I just had one call code that I would keep reusing, but Google Meet seems to have updated some policies, and the last time I tried that, the code expired. So it's probably going to be that I'm going to have to send out a new code every single class call. So be prepared to receive many emails with many codes, and for that I apologize. If it works out that there's a better way, I'll gladly work on that. But at least for right now, the only way that I really know is to send everyone a new code every single time. I'm planning on sending out a code to the entire class, regardless of which section you normally attend, during all of our normal lecture times for all sections of Physics 1000, and also all of the lab times. So that's going to be 10 a.m. Tuesday, 12 p.m. Tuesday, 1:30 on Tuesday, 1:30 Wednesday, 10 a.m. Thursday, 12 p.m. Thursday, 1:30 Thursday, and also 10 a.m. Friday. I'm doing this to give everyone the option of when they listen in, because I know that maybe you have a slightly different schedule now. Maybe you want to keep to the same old schedule. Maybe things are different for you in your current physical situation. So I want to give you guys that flexibility. You can attend any of the calls regardless of whichever one you are normally signed up for. So if you normally attend the 10:30 lecture and you just rather listen in on the noon one because you slept in, you are welcome to. Additionally, as part of the instructional email I sent out last night, I sent links to 2 pre-recorded lessons. Those are lessons that I recorded over the summer over the same content we're going to be covering. It's the same content, even though like the announcements at the beginning refer to specifically the timetable in that summer class. So those lectures cover the same slideshows, cover the same notes. Just ignore anything talking about scheduling for the class, because that was for the summer course, and obviously the timetable is very different for that. What those pre-recorded lectures are for is they are it's probably your best bet for getting the lecture, actually, because everything's going to sort of be probably slower over Google Meet, and these pre-recorded lectures will let you go through the material. You can rewind, watch it as many times as you need to, and then you can come to these calls with your questions. These calls, I think the best purpose of these calls is to give everyone time to ask their questions and to review things. And the video lectures are best used to watch it through first, to get the basic lecture on the content, and then start coming to the calls with your questions. And with that in mind, you can attend as many or as few of the class calls as you need to. If you feel comfortable just watching the videos I sent out and you feel like you're learning everything you need to from just those, then I won't force anyone or hold it against you if you just don't log into these calls, or if you just want to watch the recordings of these calls to see get everyone's review questions. If you don't feel the need to actually sign into these, you do not have to. They are the best way for you to ask questions directly and see what other people are asking, but I won't force anyone or hold it against you if you're not signed in to X hours of calls per week. I do recommend everyone try to stick to your usual schedule, just to make coming back to it not so difficult. But if things are different, I'm just trying to give you guys flexibility. I sent out. Wait, did I send out the PowerPoint? Oh, did I not send? I sent out the PowerPoints over the email. I hope so. Let me actually, just in case, let me go into Sapling. I'm realizing I forgot to post the Sapling chapters for 5 and 6, so I will do that now. Okay, so if you've been waiting on chapter 5 and 6 to appear in Sapling, I apologize. They are now currently visible. We have chapter 5, pressure and buoyancy, and chapter 6, pressure in fluid systems. They both have their own notes section. So you know what? I'm going to go back into Google Meet and turn on, where did it go? Present mode. So I'm currently in Sapling. We've got our list of topics here on the left. In the chapter 5 section, chapter 5, pressure and buoyancy, this is another link to the same video lecture that I sent out yesterday. And we also have the notes. We also have the lab for chapter 5. This is this copy. If you use this copy instead of the one that I emailed you, it is exactly the same lab as the one that I emailed you. It's just the number at the top is different. Don't be concerned by that. If you notice that, I'm going to revise this copy, but all the content is the same. It's just a change in lab number and notation. Now, to go with this lab activity is going to use some simulators, and you guys can work in groups if you want to. If you work virtually together, that is fine. If you are able to and feel physically comfortable meeting together physically, I'm okay with that if you want to do that for this lab activity. But to assist with understanding the simulators and how to use them, there's 2 tutorials here in the Chapter 5 tab explaining the basics of each simulator. So you can come here to get the lab and to watch these tutorials to help you understand how to use the simulators in the labs. That's all in the Chapter 5 tab. The Chapter 6 tab has the Chapter 6 notes, and Chapters 5 and 6 are both by themselves very short and about the same thing. Chapter 5 is pressure and they're very short chapters. They're incredibly interlinked, and so I have combined the two into 1 week of instruction. That these two combined will be about what one chapter normally is for us. So don't be worried about any sort of timetable adjusting. Don't be worried that this is going to be too much in 1 week. These were both short chapters to begin with, so them being combined isn't going to be an issue. Because they've been combined, there's only one lab for both chapters 5 and 6, excuse me. So this lab here, it's the same document I emailed you yesterday. This is the one lab for this week that refers to content in both chapters. The lab and the homework and the quiz are currently set to be due next Tuesday, trying to keep to that timetable. If anything needs to be adjusted, if it does take us longer than I plan to get through this week, I will move the assignments back as I usually do. But all that information is here for you, and the chapter 5 and 6 combined Again, we're going to do them both together. The combined Chapter 5, 6 homework and quiz are also now available for you to start looking at on Sapling. So if I was to go ahead and give you guys your direct instructions for what's to be doing this week, your instructions in order are: watch the recorded video lessons, the recorded links that I sent you, because it goes over all the material. You can watch it on your own time, however many times you need to, whenever you want. Watch those videos, come to the class calls with your questions, and begin working on the lab, the quiz, and the homework. The homework and the quiz are available to you on Sapling already, and the sooner you look at them in the lab, the sooner you can come to these calls with questions. This is going to be our basic procedure for these next 2 weeks. I'm going to give access to you the notes and a pre-recorded video if you wish to use that, and then we will have all of our meetings this week so that I can discuss things with you. When I send out links to the lab times, I'm going to send out links to the lab appointments. If you are working on the lab on your together in a group and you feel comfortable and you don't have questions, you don't need to sign into those calls to do the lab. Think of them kind of like office hours. I will be available in the call on camera for people to jump in as they need to. You don't need to be sitting in front of, you don't need to be logged into these calls all the time. If you don't need the content, if you don't need to be here or you can't be here, you don't have to be. I'm trying to give you guys as much flexibility as possible because, yes, things are weird right now. So I'm defaulting to trying to make things as convenient for you guys as possible. I think I've covered most of the basic information. I'm going to stop screen sharing now. With all of that information, and a lot of that is just me vocalizing what I emailed you yesterday, if anyone has any questions, now's a good time. If anyone needs any clarification about how things are going to be working, what you need to be doing, now's a good time to ask. You can either ask audio, or you can just type in the chat. I'm going to give everyone a minute or two to do that if they need to, while I take a quick sip of water. Even remotely, we should all stay hydrated. Excuse me. Sorry about that. Okay. So, again, and during these calls, if you have any questions at any time, speak up, post in the chat. I'm going to keep the chat feed open. I'm going to listen for when the little indicator goes off. Anything, anytime, please. Now, if no one has any objections, I'll just start going through the Chapter 5 material. It's going to be about pressure. We have shifted away from Test 1 material, the first core of the class, and we're now sort of in Core 2. This section, the first section was about what I'd call mechanics. There's just physical motion, the physical forces that make things move. Now we're going to be shifting focus somewhat, and we're going to be looking at the combination of pressure and eventually thermodynamics and how they all tie into each other. If you've ever taken much in the way of upper-level chemistry classes, this will be familiar to you. This is a lot of the physics that goes on to inform the pressure and the temperature and the heat and thermo aspects of chemistry. So now this week is going to be about pressure. We're going to move on to heat and thermo in the next couple of weeks. But right now, it's just going to be pressure and how it affects objects that are solid and that are not solid. I had another point. In the process of grading everyone's test 1, some people have already gotten their scores. Some people have not. They're just going out in the order I received them. And so keep an eye out. I will be replying to the email where you sent me your test with your score and a brief list of things that, like a list of your errors. And if you have any questions about any of the mistakes you made or how I describe them, please, again, email me if you have any questions at all about the score that you get. The test grades will be out to you this week because midterm grades are due this Friday. And for those who are either new to PC or for those who are new to PC, the midterm system is basically just a midterm check-in. It's just a, are you passing the class or not, check midway through the semester. So I'm going to be finishing all of your test grades and sending out the midterm report this week. And if you have any questions about any of your grades or how the midterm works or what your midterm ends up being, again, send me any questions anytime. Okay. If you have any questions or objections or issues, please let me know now. Now I'm going to begin going over the Chapter 5 material now. I'm just going to start going through the Chapter 5 notes with you guys. This is, again, the same material in the pre-recorded lecture video that I sent out. It's exactly the same material, so if you have the even virtually, I still stumble over my own words. If you would rather learn from that pre-recorded video and you feel like you've gotten the information you need and you can watch that video later, you don't need to remain in this call if you do not want to. The main idea for these is so that people can drop in and out as they need to during the week. But if you want my direct instruction right now, please stay. We're just going to go through the Chapter 5 notes, and what I recommend you guys do is pull up the notes and have them on the screen with you. Oh, sorry. Oh, yes. Thank you for asking, Dorothy. I did have 2 people do physical tests for me. I will send out an email with your test score as I grade those. So thank you for asking. Yes, I will make sure you get your test. Anyone who handed in a paper copy. So, staying in the call for just going through the Chapter 5 notes, I recommend you have the slideshow up on your screen, and I will say as we go what slide we're on. So just pull up the Chapter 5 notes. You can find them either on Sapling or on the email that I sent out. And just so that you know which slideshow we are talking about, this is what the first slide looks like: pressure on solids and fluids, Physics 1000. The title slide is a nice deep blue. All the other slides are a white with blue accent at the top. So this is the slideshow we'll be going through, and we're just going to go through the material like we would in normal lecture. Again, if you have any questions or concerns, please voice them now. As I take another quick sip. I honestly find that my throat dries out even faster in these remote lectures just because I end up doing more nonstop talking. It's just how the medium works. All right, so pressure on fluids and solids. Title slide just has that on it. All right, let's move on. Again, I recommend you have the slideshow up on your screen. We are going to begin by talking about, we're going to be talking about pressure this week. And before we define pressure, I'd like us to define what pressure is going to be acting upon. Pressure, and I know we've all dealt with the social concept of pressure. Before we get into the physics definition of pressure, I want us to define the things that pressure acts on. So we're going to be examining what pressure does when it acts upon states of matter. And to go over that information quickly, let's just redefine some of the specifics of various states of matter. The three states of matter that you guys are most familiar with because you've been interacting with them your whole lives, also your body is made of them, are solid, liquid, and gas. You're familiar with this concept. Liquid if they're warmer than that, and then gas at their warmest. Good day to whoever joined. I am recording this lecture. Whoever joined, if you want to rewatch what you missed earlier, and if you have any questions, please let me know at any time. The main features of solid, liquids, and gases that I want you to know for right now is solids. We consider solids to have a definite shape and a definite volume. So we can, a lot of your body is solid. Most of the objects you physically interact with are solid. We know that solids have a tendency to be very tightly compressed. The atoms and molecules that make up solids are very tightly packed into each other, and they're very rigid. They retain their shape. If I have a meter stick, this is my 1 meter long sword made out of a meter stick and a ruler, so it is good for defense and also good for measuring things. This is a solid object, meaning that it occupies this object, unless something irreparably happens to it. This object will always be in this shape until something comes along and physically breaks it. It has a definite shape. This meter stick will always be meter stick shaped until you break it or burn it, etc. It also has a definite volume. You can measure the physical dimensions of this solid object and tell me what its volume is. And the only way to really change that volume is to physically alter the object. Again, you can break it, set it on fire, hit it with a hammer. You have to physically change the object in order to change its shape or volume if it is solid. To go through the states of matter, you tend to increase temperature. So if you have a solid like ice, and you increase its temperature, it will eventually transform into a liquid. Liquids we consider to have a definite volume. Liquids have a definite volume. Whenever you get like a gallon of water or a 2 liter of soda, Those are measurements of the volume of the liquid that you have just purchased. And 1 gallon of water, you can take the water inside of that gallon jug, put it in a different container, and it will still be a gallon's worth of volume. But it won't be the same shape. I have, as you probably know, a lot of water in this thermos. And if I poured this water into any other, it would still occupy the same amount of space. If I have 2 quarts of water in here, it will take up 2 quarts of space, but it will change shape based on what vessel it's in. So, solids have definite volumes and definite shapes. Liquids only have definite volumes. They don't have definite shapes. Their will be defined by the external pressures acting upon them. Following along from that, if you increase the temperature of a liquid, it will eventually transform into a gas. Gases don't have definite shape or definite volume. I hope that I hope that you guys are familiar with like the helium tanks that you might get at a party store. The type of tank that you would use to fill up a bunch of helium balloons. If you've ever utilized or seen one of these tanks utilized, you tend to be able, like the tank itself might be this big, like a propane tank. It might be really narrow and really tall. And you tend to fill up a lot of balloons from the one tank. You can fill up a much bigger volume of balloons than the volume of the tank itself. There is a lot of helium gas crammed into one of those tanks. I suppose I should actually draw an illustrative picture here. So this is just like a vertical tank of helium. It has a definite volume, a definite width and a definite height. And this one tank, you can fill up tons and tons and tons of balloons from this one tank. And the balloons can occupy more volume than the tank itself. So the gas inside of the tank, it was originally tank shaped. It took the shape of its container and it was crammed into this volume. But once it is out of the tank and no longer under the immense pressure of this very thickly lined metal tank, it can now occupy different shapes with different volumes. The volume changed when it entered an environment under a different amount of pressure. There is so much helium gas crammed into these things, which is why they are usually very thickly lined and why you don't want to damage them. Because if the tank breaks, helium, like there's more helium in it than you would expect. It's going to all rush out at once, possibly explosively. This is one reason why, at least in movies, like gas tanks and propane tanks tend to blow up in movies. It's because they're so full of the material crammed in there, and it occupies a much bigger volume once it's free and under atmospheric pressure. A lot of the explosion isn't fire. The explosion is just the gas escaping and changing volume rapidly. So gases, they don't have a definite shape or a definite volume. You can cram a gas into any shaped container and you can force it to change its own volume. So we're going to be studying pressure and how it affects each of these different types of things. We're going to start with solids, how pressure acts on solids, and then we're going to transition into liquid and gas. Now, even though there's 3 states of matter that we're familiar with, they're divided roughly into 2 different categories. Solids are solids. They have their own unique, very specific behavior. A solid object is a solid object and will exhibit solid tendencies. But Liquids and gases occupy a different space. These two are different phases. They have some different tendencies. Again, liquids have a definite volume, whereas gases don't. But both of these types of states, both liquid and gas, count as types of fluid. Fluid is a word that in common English vernacular is occasionally misused. A lot of people will say fluid and you automatically assume water or liquids. But the word fluid does not refer exclusively to liquid. Fluid refers to any type of substance with fluid tendencies. And fluid tendencies are any object that lacks a definite shape, anything that lacks a definite shape and that will flow. Liquids can flow. You can pour liquid out of a container and it will flow. Gases can flow. That's literally what the wind is flowing gas. Both of these states lack definite shape and can flow. That means they are both types of fluid. So in this class, when I say the word fluid, it could mean either one. They both exhibit fluid tendencies, and so we're going to look at both of these in the fluid section, and solids are sort of branched off in their own little category because solids don't flow. This one object, part of it's not going to pour off while it's in solid state. If you melt it, it'll start flowing, but when you melt it, you turn it into a liquid. Again, it's probably, I'm going to give time pauses for questions, but if you have them, please interrupt me because that'll definitely be the fastest way to get your questions in. This has all been sort of a preamble based on slide number 2. A couple more small pieces of information from this slide. There's only about 2 types of, okay, there's more than 2 types of solid objects. Various examples of solids include crystalline solids, like crystals. They have a very geometric atomic shape, and amorphous solids, which tends to be most things that aren't crystals. Those are just 2 different types of solids. You've interacted with these different types before. Another fact that is good to understand is that even though these are the 3 states of matter that we are mostly going to be talking about, and the 3 states of matter that you interact with the most, there are more than 3 states of matter. These are the most common ones, at least the most common ones on planet Earth. But there do exist others. The most famous and most common other state of matter is plasma. And kind of like how when you heat up a solid, it'll become a liquid. You heat up a liquid, it'll become a gas. Plasma is sort of the next step after gas. When you heat a gas up so much that it begins exhibiting very strange electromagnetic tendencies and it starts emitting light. So we consider it its own unique phase of matter because it has different properties to just the gas that it once was. And plasma is important to know about the existence of because the sun is made, stars are made of plasma. They are superheated gas that give off as radiation heat and light. So even though these 3 are the most common states of matter on planet Earth, the most common state of matter in the known universe is actually plasma, because stars take up more mass than planets and more volume than planets, and stars are mostly made of plasma. So looking at the universe as a whole, most of the universe is plasma, but most of the Earth are these 3 things. Some places where you might have seen plasma on planet Earth is actually in light bulbs and fluorescent signs. Because when you run electric current through a gas, that can also turn it into plasma, and plasma gives off light, which is why your light bulbs work. They're usually filled with a gas. You turn the gas into a plasma for a quick second, and it just gives off heat and light. Lightning does this too. The reason you can see lightning is because it turns the air into plasma for a second and creates light so you can see it. So plasma exists on Earth. You have interacted with it. But these are the three most common states. These are the ones we're going to be referring to mostly in this chapter. As I'm erasing the board, ask any questions if you have them, and we're going to move on to the next slide. This is slide 3 of the slideshow. It has 2 definitions on it, 2 formulas actually.
A quick question.
Yes, and can you speak loudly and clearly, because your microphone, it might be my speakers, but your microphone's a little glitchy.
Sorry. I was wondering if plasma was fluid as well.
Plasma is probably a fluid. Plasma is kind of unique due to the fact that because when you superheat gas that much, it starts behaving very strange electromagnetically. So it tends to clump together like, well, the sun pulls itself into roughly a sphere for a lot of reasons, one of which being the plasma reacts to the magnetic fields and likes to clump together. Plasma would probably flow. It's just it's lumpier than gas is normally because of the electromagnetic forces. It likes to pull itself into a specific shape, and because it's so hot, like literally hot and electrically charged, it's very hard to put it into a container and then make it flow. But it is probably a fluid. It is probably a type of fluid. It's just a very weird fluid, I will admit. That is an excellent question. Thank you. Anyone else ask anything? So, moving on to slide 3. This slide has 2 formulas on it, and these formulas are definitions. We're going to use them to define 2 terms. Now, this is another unfortunate case of the fact that physics ran out of good letters a long time ago, because we've started repeating ourselves, and there's an unfortunate similarity between a few of these things. The 2 definitions we're going to go over are the concept of density. Keep in mind that is density, not destiny. I say this because I'm definitely going to say it wrong at some point. So this is density, the physical principle of density, and the physical principle of pressure. Pressure is, again, what these chapters are about, so make sure you are understanding this concept and these units as we talk about them. Density should be something you're familiar with. It's a physical principle. It's a way that we physically measure properties of objects. And the density of an object refers to how closely packed together the particles that make it up are. The formula for density is mass divided by volume. The density of any object tells you how much matter, how much stuff is crammed inside of a specific volume of space. Objects, okay, has any, there was a video that was circulating the internet some time ago where a gentleman from the UK was talking about a pound of steel versus a pound of feathers. And during the video, someone set up a physical scale on which they placed 1 pound of steel on one side of the scale and on the other scale side, they placed a pound of feathers. Now, pound is a measure of force. Pound is weight. So that tells us that the weight on both sides would be the same. That should also tell us that the mass on both sides is the same. You have the same mass of steel here as the mass of feathers over here. They have balanced out on the scale. But steel and feathers have very different densities. Notice, and I know this is a quickly hand-drawn picture, but the point stands, even though the mass on either side is the same, the volume that they occupy is radically different. Steel is a much higher density object than feathers is, meaning that for you to have the same mass of steel, it would need to occupy a much smaller volume. Meanwhile, the feathers have a very low density. So in order for that to have a very high mass, it needs to take up a very high amount of volume. So the density tells you just how much matter is crammed inside of a specific volume of that type of a substance. The more dense something is, the more matter is inside of it at that specific volume. Now, again, physics letters a long time ago. We were using the Latin alphabet. We started stealing things from the Greek alphabet. And between those two alphabets, we still ran out of good letters. So I know that we used rho for momentum. But frustratingly, some people also use rho for density. So this formula is the density formula. Density equals mass over volume. I hate that the unit repeats, that the variable repeats. And I am sorry that the variable repeats. Which is why I'm going to cluster the formula sheets into different sections. On the formula sheets, I'm going to make sure that the formulas are in two very different and labeled sections. Additionally, the next test that we do, the chapter 5 through 8 test, won't involve much of the mechanics material from the first test. So you're not going to need to use momentum and density together at the same time. Do kilograms over liters. You could also do kilograms over meters cubed. Liters and meters cubed are both different units of volume. Good day to whoever joined. I am recording this lecture if you'd like to go back and watch what you missed. So density, it can be measured in kilograms per meters per liter. It is always some unit of mass over some unit of volume. It is defined as mass over volume. The second definition on this slide that we need to go over before we move on to the rest of the chapter is the definition of pressure. Now, I know you've all felt social pressure before. You've also felt physical pressure before, so we're defining physics pressure here. Wasn't a very good joke, I'm sorry. Listens to a weather report, people complaining about, say, the air pressure. Then you are probably aware of the fact that there is presently air around you right now that is exerting pressure on your body. On Earth's surface, there's a certain baseline air pressure level at all times. So on Earth's surface, there's a certain amount of air pressure on your body right now. That's because there's air all around you pressing on you. You don't really feel it because the human body is designed around that. We are designed to be able to ignore it. Our bodies are designed to take it into account, which is why you don't notice surface level air pressure. But if you go very far underwater, you'll feel a different amount of pressure because now there's also water pressing on your body. So when you're surrounded on all sides by air or surrounded on all sides by water, that fluid, there's that word again, fluid, is exerting a force on your surface area. Every object has a surface area. Granted, we don't have a formula to calculate the surface area of a human being, but everything, including people, has a surface area. It is the square footage of the area that makes up your exterior. And there is a force pressing into that area due to the fluid that you are surrounded in. If I hold my arm out, there is air from above my arm pressing down on my arm. And it's because gravity from the earth is pulling down on the air. You don't usually think about it, but air has mass, therefore it has a weight. Gravity is pulling down on it, and literally the weight of all of that air is exerting a force into your body. And it does this evenly across your entire surface area. The air above my arm is going to press down into the area of my arm, but the air beneath my arm is also going to press up on the area of my arm. It does so uniformly across the entire surface area of an object. So if I was to draw the rough silhouette of a person, so we have a roughly human shape here. This being has a surface area, and the air is always going to be pressing perpendicularly into their surface area all the time. This is always happening. And the force is always perpendicular to the area. Notice that on the vertical pants leg or the vertical shirt sleeve, the force comes perpendicularly inwards. But on like the curve of the shoulder, I drew it so that it points perpendicular to wherever that part of the curve is. This force over your surface area is the pressure that your body is physically under right now. Pressure is defined as force spread out over a surface area. The higher the pressure is, the more force it exerts on that surface area. So the higher the air pressure is, the more force the air around you is exerting in on your body. If you've ever gone or heard about deep sea diving and pressures that divers are under, the further down you go, the more force the water exerts over the area of your body, which is why you feel it all over your body. So this is the definition of pressure. It's a force exerted over a surface area. Now, pressure is a new variable. This is how you calculate it. The variable for pressure is a big capital English P. This is a big letter P, as opposed to this lowercase rho. So this is a big uppercase English P. And the unit for pressure, there's actually a few of them. The main one that we're going to be working with in this class is pascals. The primary unit of pressure we're going to interact with is pascals. Other units that exist include atmospheres. So some scientists just measured what is the standard atmospheric pressure and made that a unit. So right now your body is under 1 atmosphere of pressure if you are currently where I am at sea level. There's another unit of pressure called millimeters of mercury, which is a very old unit that was used primarily with old thermometers. So these are all different units of pressure. We are going to mostly be using pascals because that is the metric unit of pressure. Now this is where a normal class period would end. So I'm going to end the recording here because if nothing else, I need to eat lunch before my next lecture. Again, you can drop in or out of these calls at any time. This is all the same material that has gone over in the pre-recorded video lecture. So I do recommend you watch those. You can watch them when on your own time and then come to these with questions if you have them, but I'll still be in here going over the information anyway. I will be making this recording available to anyone who joined late. Again, I'm not counting attendance. You can drop in or out as you need to or as you are available, and you can attend any call you want. I'm going to have another call at 12:30 for the H lecture. I'm going to form another call at 1:30 when the lab would normally be. You're welcome to come in and ask about the lab, but you can also come in to ask about anything else. You also don't have to come if you don't want to. So I say we're off to a good start. We've talked about the formulas. Talked about all the rules and things that we're going to be doing this week. Thank you all. Again, please let me know any questions you have. You can stick anything at all. Sorry, microphone on. Does someone have something?
I had a quick question.
Yes.
My normal schedule was Tuesday, Wednesday, Friday, and they were all at 10 a.m.s. Are all the pre-recorded lectures, like, are you going to pick right back up on the next day, right where we left off?
Yes, unless someone has another particular issue that I'm hoping for these calls to mostly be questions because the lecture, the material is the same as in the recorded one. So I do recommend you watch those because then you can come primed with any inquiries that you have. And that way you don't, if you come at your normal times, I will be continuing through the material, if that was your question. I'll be having classes these calls at all the normal times if you're trying to keep to the same schedule and habits. Does that answer the question? Sorry.
Yes, it does. Thank you.
Okay. You're welcome. Thank you all again. I know this is going to be sort of a weird couple of 2 weeks, but I am going to work with you guys to make sure that it is a success. We can have a smooth transition into this 2 weeks and then back out of these 2 weeks. I do hope you all have a great day. You're again welcome to sit in on the next call as well. You're also welcome to come at 1:30 if you have lab questions or any questions at all. The lab times will be pretty much just study sessions for whoever wants to come. Thank you all very much. Sorry to keep you as I've been wrapping up here, and I do hope you all have a wonderful day if I don't see you.
What day is the lab due?
Next Tuesday. It'll be a 1 week thing.
Okay.
Yeah. Excellent question. Thank you. All right. Anything else? I know I've held you guys for a little bit. I'm sorry. It's okay. Feel free to filter out as you need to. I'll be making this recording available. Thank you all and have a wonderful day.